Hello, everyone.
Hello.
Yeah, welcome to the session. I think we have all the presenters here. Mm, yeah, I think we're still missing the presenter for the second paper. Uh, did I miss anything?
I think the author Yunlin is here for that paper.
Okay. Okay.
Hi,
Hi.
I'm here.
Okay. Glad you're here. Okay. So we are go ahead and start. So our first paper is called AI Search, the searching for API-related resources from Stack Overflow and GitHub. And in the chat box, you may find a link to the details of the program. You will see the all three papers and the authors and the abstract and the demo link, so on and so forth. So let me know if you have any question. You can raise your hand and type your question in your chat box. And now I will just give this to King to present their paper. King, you can start to present your paper.
Okay, sure.
Mm-hmm.
Can you see my screen?
Yeah.
The slide.
Yes.
Yeah. Okay. Hi everyone. I'm Kin. Today I will talk about the tool demo paper AI Search, which is searching for API-related resource from Stack Overflow and GitHub. And Stack Overflow and GitHub are two popular platforms containing the API-related resources for the developer to learn how to use the APIs. The platforms are a good source for the information about the API, such as code example, the users, bug report, so on. However, it's difficult to collect the correct resource regarding a particular API due to the ambiguity of an API method name. So, an API method name mentioned in the text would only refer to one API. However, the method name could match different APIs. To help people in finding the correct resource for a particular API, we introduce the AI search. It finds the Stack Overflow threads that mention the particular API and their relevant code example from GitHub. AI sort, it has three main components: the resource database builders, the resource database updater, and resource retrieval engine. The resource database builders collect an initial set of the API-related resource, which are the Stack Overflow threads and the GitHub code example. It then stores them into the resource database, and then the resource database updater can then be used to add additional API-related resource to the existing resource database. And the final component, resource retrieval engine, retrieve the API-related Stack Overflow threads and their relevant GitHub code example when the corresponding API is queried. First, to build the resource database of the API methods, AI search use the two words, Facus and AU search. As there's a ambiguity problem available on GitHub and Stack Overflow. Uh, for example, the Java word may refer to the Java island, or it also refer to the Java programming language. So, a simple name of the API method can also be ambiguous, as they are mentioned as a single word. The ambiguity can occur between a simple API name with another simple API name, or between a single API name and like a natural language word. Focus is the tool used to find whether a Stack Overflow thread correctly refers to a specific API method by resolving the ambiguity. And AU search is a tool created by Azerov et al. And it leverages the type system and the API method signature to accurately resolve the ambiguous API invocations in the code examples available on GitHub. Uh, in the beginning, the result database is built and indexed using a limited set of API-related resources. The maintainer of the tool can easily expand the resource just by running the two tool Facus and AU search to access the new set of APIs and then execute the result database updater script to put the API related resource into the resource database. The final component is the resource retrieval engine. It helps quickly retrieve the index, Stack Overflow thread, and the GitHub files of a specific API and show them to the end user. So the figure here shows the user interface of the resource retrieval engine when searching for resource from Stack Overflow and GitHub. It allows the user to type a fully qualified name of the API method um, into the search bar here, and it retrieves the Stack Overflow threads and their relevant GitHub code example from the resource database. For the Stack Overflow threads, each thread is displayed with the title, the link, and the portion of the content centered around the position where a query API is mentioned. And the code example here on the right hand side are the most relevant code examples for Stack Overflow thread. That was about the AR search tool. Thank you for listening.
Thank you, Kim. Do you have a live demo to show, or if not,
Yes.
you can. Okay, go ahead. Just go ahead.
Okay.
Yeah, we will start the discussion after the demo.
Wait. Actually, I have some problem with the live
If you have a
repairing the
recording,
tool,
it's
so I
okay.
have a recording.
Yeah.
Yep. Can you see the slide? Assume that Bob is a Java junior developer who is learning a library called Mockito. Bob goes to the documentation page of Mockito and he sees on the method chain with when and then return method. He doesn't know what this API method do, so he looks at the explanation under the example. However, because the explanation is pretty high level, Bob wants to know more about the low level of API method, then return to be specific. So he searches the Java doc and finds the fully qualified name of the API method, which is org mockito.stopping.ongoingstopping.then return. So he starts searching it on Stack Overflow. He tried finding the discussions on Stack Overflow to understand more about the method. But there are only 3 examples and none of them looks potentially having the result that Bob is finding. Because of that, he switched to another query that separates the fully qualified name of the class and the API symbol name as two terms. The results are more than the previous query. However, they most likely come from Mockito library for Scala, and they are not the resources that Bob is looking for. Because Stack Overflow used exact terms matching for shirt, Bob has to keep changing the query format. This makes Bob tired and he tries using the AR shirt tool. He just needs to query using the fully qualified name of the API method, then return. After that, the tool will return the related Stack Overflow threads referring to the API method. Looking at the first result, the preview content seems mentioning the method chain that Bob is looking for the explanation. He tries clicking on the link and it redirects him to the Stack Overflow thread. Luckily, the thread has the answer that Bob was looking for, since it is considered as relevant to the API method by AR search. Not only showing the resources from Stack Overflow, on the right-hand side, AR search also gives the course examples relevant to the Stack Overflow resource. We also can access to the GitHub link of the code examples by clicking on their link. The GitHub file also highlights the method invocation.
Thank
Um,
you. This is a very interesting tool, and yeah, this looks very useful. Yeah. And so I would see any questions from our
Um,
attendees.
I have a question.
Go ahead.
So how to rank the code snips from the Stack Overflow or GitHub candidates? Because you can get lots of results related to an API and how to rank them.
um, well, actually, I don't really understand what does rack mean.
Um,
I think you're
give an order of the candidates.
ranking. I think she's asking about ranking. How did you rank the candidate results? What heuristic did you use to order them?
Yeah. For that, I think first we need to find the from multiple TPL. Oh, sorry. I mean find from multiple libraries to extract the fully qualified name of them. Then we group them by the symbol name. So we have different the fully qualified name candidates for API.
Yeah, and I think her question is about you have multiple candidates, and which one, how do you weight them? Which one do you prioritize the first? How do you prioritize them? How do you order them? If you have like five of them, which one did you pick first? Which one did you show at the top?
Yeah. Currently, it is based on the matching mechanism of the Fakus tool. But if they are, from multiple APIs that have the same symbol name and the the type. So we just currently we can only filter and select the first one, the first example first.
Oh, okay. Thanks.
Okay. So I think as a follow, any questions from others?
I have a quick clarification question
Mm-hmm.
regarding the GitHub links. So how do you map? Do you just find where the function or the method is implemented, or is it the use of that method? And if so, in which repository? Is it all GitHub projects, or yeah, how does it work?
Actually, for we find the Stack Overflow thread talking, referring about the API. Then we also find the GitHub files refer to the API. The main refer here is like talking about the users. So it also is the method invocations, and it's also is the like the re-implement. That's how people use and re-implement the API method. And the way that we link the Stack Overflow thread to the code examples is that we use word it's on the vector space model to find the relevance between the content of the Stack Overflow thread and the code example. And so we rank them and choose the top one to show as the code example for the thread.
As a quick follow-up, are you worried about code clones in different projects, or was that not an issue when you implemented?
Yeah, actually, regarding code clone, actually we didn't consider it in this work.
Okay, maybe for future
Yeah,
work. Thank you.
yeah, sure.
Thank you both. And I think it's time to move forward. So Kim, if you can type in your email or other contact in the chat box, I think the other attendees can follow ask after the session. Thank you.
Yeah, sure.
And our second paper is called G defect for deep learning. This is a dataset of a general real-world deep learning program defects. I think Yunlin would be the presenter.
Okay.
Yeah, welcome. Yeah, go ahead. It's your time.
Thanks for introduction. So let me share my screen. Let me see. So can you see?
Not yet.
So can you see my screen?
Yeah. I can
You
see
can
your
see
screen
that?
now. Yes.
All right.
Okay.
Okay. Okay. So today I will introduce our GDFX for their work, and I'm Yunlin. I'm a research assistant professor in National University of Singapore, and this is the joint work between Tianjin University, National University of Singapore, Singapore Management University, and Fudan University. Okay, so now the deep learning program is emerging. I believe all the audience here has an experience of writing the deep learning programs. When we're looking at the GitHub repositories, when we're using a keyword like deep learning, we're trying to search the repository for GitHub. We'll get over 140 on GitHub repository about deep learning. And if we search for the GitHub issues, we'll find over 130K GitHub issues about deep learning programs. So we can see that this is really an emerging problems. And the software engineers or the software engineer researchers are trying to ask whether there's any automated tools can improve the working efficiency for those deep learning repositories, and also whether there's an automatic approach to fixing those issues on the GitHub learning programs. And the research on software engineering researchers have already proposed a lot of the benchmarks datasets in deep learning bugs, and they will serve as the facilities for deep learning programs. And then I list a few, but I think there's more emergence. When we're looking to when we apply the qualitative analysis on the bugs in the dataset, we find that they're all excellent work. But one of the limits is that on their bugs is not that educational, which means that the knowledges on one bug can hardly migrate to the other projects. So here's examples. And this is about we're coming from one of the data set, but this is not just a single examples. And in this data set or in these bugs, we can see that the CNDA transformation is a very project-specific knowledges. Of course, we can see the commits, we can see how it is fixed, and these are all very project-specific implementations. If we want to apply this knowledge to other projects, it will be very hard. In contrast, there's another kind of bug on which is more friendly for migrations and more educational for the other programmers. So this example is for the TensorFlow, which using a log function. And without that, from the mathematical point of view, and when the input of the log function is close to 0, it will give us it will give a very large negative number. And when we run the programs or when we execute the TensorFlow programs, we will always introduce not a number errors when the output is close to 0. In addition, this log function is frequently used in many loss functions. So there's a lot of fix to address this problem. The problem is very common to happen, and there's a lot of fix. So in these examples, we can see that there's clip by value functions which control or constrains the range of the values. Also, in other projects, we can find that there's other kind of fix, and the bug happens, and there are other kind of fix using a different API to address the problem. So we argue that it is not just the scalability of the dataset that matters. In addition, it also matters whether the dataset is more informative and the bugs are more representative, and that also very important. So we propose our GTFX for DL tools, and the first goal is the generality, and we want the bugs can be well generalized to other projects, and if the if the bugs not is less educational for human programmers, it will be very hard for the algorithms derived from the dataset to be generalizable to the other projects. And we hope that each bug in our dataset can be maintained with setup bugs with similar root causes and fixed solutions. And the second, we want the bug to be authentic. That means the bug happens in the real projects should be with a very complete and educational context, such as whether there's some GitHub issue discussions, and what about evolution history, and whether there are regressions on these bugs. And the third is that we would like to have an isolated environment, which means that the bug need to be replicable, and we provide both the Conda and the Docker environment to replicate those bugs. And finally, we hope that the bug dataset is supposed to be friendly for two integrations. In this dataset, we introduce Shapeflow, Debar, and Grist. And in this dataset, it is not a very large dataset. But actually we say it is kind of representative. It consists of 64 general bugs of 6 types, including shape mismatch, API use, numeric error, etc. On how we construction the GTP4DL, we follow this workflow. So we first start the constructions from the GitHub issues, the closed GitHub issues. So from a variety of the GitHub repositories on deep learnings. And then we try to find the fix, and how do we fix it? How do the developers fix these issues in terms of code? The idea is that we go through the description of the GitHub issues, we find if there's any description of the commit, and then we search the commit to find whether there's a mention on the GitHub issues. By this means, we can build a pair of issue comment, and we're only looking to these kind of pairs between issues and commits. Once we got these ones, we find that version before the commit is a failing version. The version after commit is parting version. And there the fix between the difference between failing and parting version is supposed to be fixed. And we also, in order to check whether the fix is kind of journal or the bug is kind of journal, we look into two aspects. The first is that if this fix is kind of similar to other CROD fix, so the more fix it is similar, the more likely to be a journal. And the second is that we also have some domain knowledges on deep learning programs. So we also can manually evaluate whether certain fix on is a domain specific, project specific, or it is a very general one. When we select those general bugs and we manually construct test cases, and then we construct the conda and doc environment to replicate the bugs. And our approach supports both the web front end and the command line. The web front end is for people to have a more intuitive understanding what the bug looks like. And the command line is used for second programming platform, which means that we provide APIs and the developers can build their tools based on the dataset. And this is links. So given time limit, I can only show the web front end. So you can see the screen. This is a website we have. Assume you can. So in this on GitHub website, so this is on public address, but if you install the GTFX 4DL, you can also have this website on your own client. So first we have overview of the GitHub, and then for each bugs, we first allow you to pull the environment. We also maintain the Docker environment. We also maintain the environment on Docker Hub. So when you click the pull, you can actually download the environment. And once you pull the environment, you can look into the details. For each bug, we have a bug ID on error messages and the port level. The port level means that how many bugs in the dataset share the same root cause and the fixed solutions. And also can show what is the similar bugs here. For this bug, we can look into the GitHub issue, which is why it is and what is the problem descriptions of the bug. We can see that the problem lies in not a number errors. And when we look into how it is fixed, we can also see how it is fixed in the GitHub issue. Of course, this is just a description. You can also run the bug to see how the bug actually happens. And also you can see how it was supposed to fixed on what is supposed to be fixed solutions. Since this is just a web front end, you need to check the source code for more details. And similarly, if we look into the similar bugs, it will have a similar descriptions of the bug. So it is just also a problem of not a number errors for the cross entropy loss. And you can see that these two bugs, despite they have the same root cause, but they may be repaired in a different way. Yeah, so that's all for my presentations. And any questions is just welcome.
Thank you.
Hello?
Yeah. I think you kind of combining the talk and the demo together. Or you
Yeah.
should, yeah, okay. So any questions, welcome.
I have a question. So how do you locate the bugs in the repositories, and how to identify it, and how to find the similar bugs with it? What is the
I think I
approach?
have mentioned. I think I have mentioned these. So the idea is that when we look into the GitHub repository, we started with a closed GitHub issue, right? Suppose the GitHub issue is closed, which means that we believe that there's issue has been addressed, in terms of may or may not in terms of code. But to further confirm whether it is a fix, we also to see whether there's a GitHub ID mentioned in the issue description. So some developers and authors will say, I fix these issues by this commit ID. But anyway, so this is just automatic approach. So in order to confirm whether this conform to your expectation, we look into the messages of that GitHub ID. Oh, sorry, the Git commit ID. And we'll see whether the messages also can reference back to the issue ID. So we build a kind of a stronger link between the issue and the commit. By this means we confirm there's an issue. Sorry, there's an issue being fixed in terms of code. All right.
Yeah.
And then we
Thank
look
you.
into, so since we have the code, so since we have the fix, we have the descriptions, we can calculate the similarity between the bugs so that we can find the general bugs in somehow in this way. But definitely we need some manual inspections to further confirm whether this is really general.
Oh, so you leverage the maybe some text similarity calculation algorithm
Basically,
to
we're using the code similarity.
a code similarity. Okay.
Yeah, for example, some kind of API is misused repetitively. For example, the cross entropy is fixed repetitively, but it's okay they are fixed in a different way. But as long as the line of code has been changed in the fix, and we will take care about this one.
So is there any false positive cases?
Oh, definitely, it's not a. It is not a. It is not a full paper. It's not a technical. We don't claim it's technical contributions. It's just more like a semi-automated approach for saving the effort of human inspection. Otherwise, the effort
Thank you.
is very costly.
Okay, thank you. That makes sense.
Any other questions? Oh, I think there's one. Are there any different characters? I think Yunhua have a question here. Are there any different
You mean a
characters
chat inside the chat?
in the chat? Can you see the question?
Yunhua Zhao, right?
Yes.
Okay, so what?
Yes.
So the question is, are there any different characters compared to normal code defectors? I think the idea that for normal defects, the bugs of the normal defects, I think it is kind of similar, but we claim it is more representative for the because it's general. The knowledge is migrable to the other projects, and also we provide more sophisticated uh, isolation technique, including both Conda and a Docker environment. Conda for lighter weighted replication and a Docker for more heavy weighted replication. In addition, we provide the API documents. I think we look into, because the neighbor bugs kind of small, so we put more efforts to maintain more elegant way to represent it. And also, I believe the approach can be generalized. For example, based on the same approach, we can keep increasing the scalability of the dataset.
There's another question coming up. Can you see that?
Yes, so Matthew saying that he has two related questions. The first is that dataset is relatively small, and do we have any plan to expand it? If so, and about how many bucks do we expect it in a dataset to be mature? Okay, so yeah, so this problem, so here we argue that the scalability definitely is important, but it is not all about the scalability. It is about the representativeness and informativeness. And we find that I suppose there's a very large number of data set, but the knowledge is less educational for programmers. That means we look into the bug, but again, nothing from the bug. It is really a bug, but the quality really matters. So we want to say that so for now defects for J, and also we have some work to mine the data set automatically. So the quality of data set, whether the bug is really generalized for us to fix and learn, so that's really matters. So here we claim that the scalability important, but representative and informative, and whether it is educational also matters. So we hope that we present more like a educational and a representative data set. So this is first our maybe kind of a defense for more data set. But of course, there's a room to improve on the scalability. You can see that we have a workflow, and this workflow have a good potential to be fully automated. But we do need to be pay some effort to make the workflow fully automated, or at least we want to further minimize our efforts to extract the bug. So that is our future work to improve it. Yeah, and also that's really good questions.
Yeah, that's actually I have a similar question too. Oh, go ahead, Mashu.
No, thank you. I really see the point in, like you say, representativeness before scalability. But maybe I can slightly rephrase my question. How many bugs do you think you will need to have a representative sample, or do you think that even with just 64, it's already a good sample to get an idea of most bugs that developer will come across?
Okay, that is also a very good question. So from my point of view, the number of bugs not matters, but the number of types of bugs matters. So if we can see that the deep learning programs is evolving, so we're always missing some kind of critical bugs, which is a common mistake for the programmers. So in this case, the idea is that we're trying to maybe go through the Stack Overflow issues and GitHub issues and have some surveys to make sure that whether the type of bugs is really enough. So the idea is that so we will also check and just do some surveys for whether the type of bugs is complete, and also we will also keep track of the evolving programming paradigms. So that means if there's new coming, or for example, TensorFlow, the PyTorch have their version updated, which introduce more common mistakes, and we also will track that kind of issue.
Thank you very much. That makes sense.
Yes, thank you. Yeah, I think I have a similar question here with you, Mashu. And I think right now, I think your research group is doing pretty much the bug creation in the background, and the users just use the front end to learn how to fix the bug, right? Maybe, and in the future, I think you mentioned a good way to automate some of the manual work to make it more efficient.
Yeah, so we have a common work which do this in a pure automatic way in
that's
studies years.
Look
and
forward to that. Yeah, this will be very useful. And another way might be crowdsourcing. Maybe you can open up the platform in the background and to
definitely
deep learning developers, they will contribute together to make this the bigger database and a more real world thing.
Okay. Yeah, thanks for the advice. Yeah.
Okay.
And by the way, that's all for the presentations. Is there any follow-up discussions after all the authors finish their presentation?
Yeah.
I mean, is there any follow-up discussions in the session?
No, I think we only have 1 hour for all of us, but you can type in your email and contact information in the chat. I think anyone who has a follow-up question, they can contact you directly. You can chat in the chatting room or something, coffee room.
Sure, I'm happy for that.
Yeah. Okay. So now we are going. Yeah, thank you. We are going to move on to the third paper. Yanjie, are you ready? Yeah. So the third paper is Yanjie is going to present their code implementation recommendation tool. Okay, go ahead.
So hello everyone. Today I will introduce our paper called Implementation Recommendation for Android GUI Component. First, I will introduce this paper. Developing the UI of an app involves 2 separate activities. The first is the design of the GUI, and the second is the implementation of the GUI. The latter usually involves the implementation of the GUI interface itself, such as GUI widgets details, layout, constraints, and handling of user interactions, such as what happens when the button is clicked. Take this figure as an example. It is a tip extracted from an Android app and highlighted. This GUI page contains various GUI components referred to these icons. Each of these icon GUI components must take user inputs such as a click or other interaction and respond accordingly. For example, when users click the profile icon on the top left, a new page will be switched to. Such behavior changes driven by user inputs are usually done by callback methods. Ideally, each icon should be associated with at least one callback method. So our tool is to help developers implement those callback methods associated with these Android GUI icons. And this figure presents of the tool. The tool is named Icon to Code. Its three key modules are database construction module, similarity calculation module, and API recommendation module. The first module, DCM, aims to pre-analyze a broad set of Android apps to construct a database mapping icon to its code implementation. And DCM takes APKs as input, and the output is a database mapping icon to API. SCM takes the database and icons as input and outputs some similar icons. And the third module, ARM, will generate the recommended API candidates. And the first module, DCM, has 4 steps, and it is mainly implemented based on some static analysis techniques. And for example, the second step, code analysis, is to establish the mapping from icon-bound GUI components and their corresponding callback methods. And the third step, call graph construction, based on the mapping from icons to its callback methods. We then harvest the set of APIs accessed by the aforementioned callback methods and consequently build a mapping from icons to their corresponding set of APIs that are invoked when the icons receive user inputs, such as being clicked. And for the third module, ARM, it leverages the traditional collaborative filtering algorithm to recommend API usages. In our tool, an icon plays the role of a user, and each API plays the role of an item. Based on the most similar icons returned by the second module, the icon to code first determines the number of API key accessed by the associated callback methods of the selected icons, and then models them into an encoding matrix. The probability of recommending a given API to the icon under edit can be calculated. The output of icon to code will be a list of Android APIs that are ranked based on the calculated scores. And thanks for listening. And I'll end first because I didn't know I should prepare a 10-minute demo, so I will play the YouTube video when
problem.
I
It's okay,
submit
yeah.
the paper. Yeah. Now I will use this icon as an example for the demonstration. This is the Python code implementation of icon to code. Since the dataset is stored on a remote Linux server, I will use the terminal to execute commands for demonstration. First, I have put the example icon in the input folder, namely the folder. Then run the script with the user-defined input and output options, as well as other default settings. Finally, we can get the output recommended API list. The first column is the API candidate, and the second column is the score for each API. Okay. Okay, thank you.
Thank you. Any questions?
Oh, sorry.
Oh, you have something else?
No, sorry.
Okay.
I think my work is a little different from the two papers because I think the biggest challenge is the static analysis, yeah, rather than the recommendation itself.
I have maybe a question about how, maybe what's your vision for the tool? I thought it was really interesting to just input some icon and get suggestions of how to write the callbacks. Well, at least the APIs to use callbacks. So how do you think that may integrate what you see is what you get editors, WYSIWYG editors? Is that something you considered, or do you just I don't know, did you work to integrate your work with these kind of editors?
No, because because it is only finished by our several PhD students, and maybe we don't have too much human effort to that. Because when we extract the APIs from the published APKs, we additionally collect the code snips related to the APIs that so we can also provide some code snips or API usages to the developers.
Yeah, I think that's what I saw in the longer video. And I mean, maybe that's just me, but it felt like a really good candidate to add that because right now we have editors to build the GUI only using a graphical editor without writing code, and it generates the code to just place the elements. So it seemed really complementary to this kind of editors. Yeah, I guess more of a thought than a
thank
comment.
you for
Right.
question. Maybe we'll leave it for future work. Yeah.
I think it's really interesting. Thank you.
Could I ask a question?
Go ahead.
Yeah.
Analysis.
I mean, what tool do you use? You said there is a static analysis. Right?
Yeah. We Java and Android static analysis tool, very well known and famous tool.
Okay, I know. But I see you Python program.
Right? The Python implementation is for the filtering algorithm, because we first extract all the data sets that we needed for the tool. The extraction is implemented on suit, and then based on the data sets and the information that we collected, we then use the Python implementation to do the recommendation module.
Okay, yeah. I know. Thank you.
Thank you.
So I have a question here, Yanjie. So so the experiment on the tool you did is all by your own research group, right? Is there any like external user case study or something like that? Did you?
Oh no,
not yet.
Because we the extraction is from the published apps, that is APKs that we collected from Google Play.
Mm-hmm.
Yeah. And so the evaluation is also based on the published
Okay.
apps.
I see.
Too.
Yeah. Okay. Any other questions? So are you currently working on some future work, future plans on this tool, or this?
No.
No, not yet. Okay.
I'm now working on some repair some compatibility issues.
Okay. Yeah. Yeah. But it's good to move forward with this interesting tool. Yeah. Yeah.
Yeah.
Okay. Yeah, I think we have all our presentations here, and I think if you don't have specific question for Yanji, we have 10 more minutes for open discussion for all three papers. If you have any questions or you want to discuss with some topic particularly? No? Okay, thank you for everyone to attending this session. And if you have any questions for the authors, then you can contact them directly or just chat them in the virtual coffee shop. Yeah. Okay. Thank you. So I think it's Yunhua, how can I do we just leave this session to close the session, or what else do I do?
Yeah, if the session ends, we can just leave. Everyone can just leave.
Okay. Yeah. Okay. Thank you, everyone. Bye.